Good morning, class. This is Mr. Walker here, and we are talking about the second half of our special solutions notes. So let's take a look at this top half over here. Now, the main thing you need to know is that when you're identifying special solutions, it's really a surface level. I'm looking at the equation and I'm noticing something about it. So if you have one solution, what you're going to notice is that with the variable terms, you have two different variable terms. So the variable terms will be different. What this means is that when you go about solving it, you're not going to end up canceling out your variables, and you'll be able to actually get whatever you have for your variable by itself, and it's going to equal some number. Now, if you have infinite solutions, what you're going to notice about the equation is that both of your variable terms will be the same as well as your constant terms. So everything will be equal in your equation. So the variable terms are the same, both sides will be equal. Now, when you're looking at no solution, you'll notice that just like with infinite solutions, the variable terms will be the same, but both sides won't be equal. So you'll have the same variables, but different constants. So you need to go through and take a look at these. You're going to need to simplify whatever equation you have, and then take a look at what you have on both sides of your equation to see what type of solution you'll have. Now, if you have one solution, you'll have to go through and actually find that solution. For these two, since no matter what you do, they're going to have these types of results, you could leave them as is. So let's take a look at a couple of examples. On this first example, what we got is we have 2 times 4x plus 5 equals 5 times 2x plus 4. Now, what you have to do first, you need to simplify both sides of your equation. So what I did was I distributed the 2 and the 5 in respectively. Over here on the left, that yielded me 8x plus 10. On the right, it gave me 10x plus 20. Now, what I noticed already is that our variable terms are different. Because they're different, that means we could solve that equation. Now, if you go through and actually solve this, you bring the 10x over here, or you can bring the 8x over there, whichever one is your preference. I'd bring the 8x over, and that would give me, that would give me 2x, yeah. That would give me 2x, and on the other side, if I bring the 20 over, that would equal a negative 10. So that would give me negative 10 equals 2x. If I continue going off from there, I would have to divide both sides by 2, showing me that negative 5 equals x. So I can solve this. What this means is there's only one solution to this equation, and there's only one x value that will make this equation true. So there's nothing else that we could plug in other than negative 5 to make this true. Now, if we take a look at the other examples, for example 2, just like what we did before, we have to simplify our equation. So we got some distribution going on here, and then we're also going to have some combining of like terms. So just like I did before, I distributed this 2 inside of here, giving me the 10x plus 8, and over here I distributed the 3 in here, giving me the 6x minus 3. Now that I got everything all distributed out, I need to go and combine like terms. Over here, my like terms are the 11 and the 8, which gives me this negative 3. Over here on the right, I have my 6x and my 4x. Those come together and give me this 10x. Now, what I notice is I have 10x here and 10x here. My variable terms are the same. And then once I look at everything else, I see I have negative 3 here and negative 3 here. That means that this side here is the same as this side. Both sides are equal. This will mean that you have infinitely many solutions. And that means that any value for x can make this equation true. Doesn't matter what you plug in here because you're plugging the same thing over here because they're exactly the same. Now for the last one we got to go through, we need to simplify. So I simplified my distribution. It yielded me this. And just like I did before, I had to simplify by combining like terms. And I noticed that this time my variable terms are the same, but both sides are not equal. That means that there are no solutions and that there is no value that can make this equation true. Catch you in class. See ya.